In this video, we'll be looking at permutation of distinct n objects. Now, permutation of distinct n objects of which n1 are of one kind, n2 are of second kind, down to nk which are of the kth kind is given as what? N factorial over n1 factorial times n2 factorial times n3 factorial down to nk factorial, where my n is equals to n1 plus n2 plus n3 down to nk. Now, just like in my introduction to permutation, I said my n represents the total number of items given to us in the question also. Now, in this example, let's see what we mean by n distinct objects in permutation. Now, how many ways can the letter of the word mathematician be arranged? Now, I'm going to be applying this formula that I just wrote up here to solve this question. But how then will I solve it? Now, mathematician can be arranged in this number of ways. We have our M, we have our A, we have our T, we have our H, we have our E, M and A already there, we have our T already there also, then we have our I, we have our C, and we have our N. Now, in how many ways can letters of the word mathematician be arranged? Now, M is on board, A is on board, T is on board, H is on board, E is on board, M is already there, A is already there, T is already there, I is there, C is there, and there my N is what? There also. Now, how many M do we have represented in mathematician? We have 2. How many A do we have? We have 3. How many T do we have? We have 2. How many H do we have? We have 1. How many E? We have 1. For I, we have 2. For C, we have 1. For N, we have what? 1. Now, how do I now solve using the formula given on board? Now, from what I explained here, together with what I have here, and then what I also have here, let's say I'm going to solve this question. Simple and straightforward. How many mathematicians do we have? How many letters, are in the word mathematician? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 words. That becomes 13 factorial. Okay, 13 factorial. That becomes 13 factorial over what? Over each of this. That is over 2 factorial, 3 factorial, 2 factorial, 1 factorial, 1 factorial, 2 factorial, 1 factorial, and what? 1 factorial. Now, where we all have our 1 factorials to be equals to 1. So let's now solve for the rest. We're left with what? 13 factorial over what? 2 factorial, 3 factorial, 2 factorial, and what? 2 factorial. Now, what does this mean? It means you should expand and then solve. That is 13 times 11 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial, over 2 times 3 times 2 times 2. How? 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2, which is this. 2 factorial is 2, and then 2 factorial is what? 2. So then you solve, cancel out where you need to cancel out, and get your answer, and so on and so forth. So in this, I'm going to have this remaining 4 times 3, relatively 4 times 3. So you just multiply whatever you get up here becomes your answer, ways.